Good afternoon, everybody. I am Indrajit Bandopadhyay. So today I am going to discuss a topic of operations research, that is transportation problem. So here you see the caption, transportation problem. We have already jotted down a matrix. So let us understand what is the meaning of the matrix, all the values of the matrix, and then we will proceed. So you see, transportation means this is the job of the materials or transportation manager. Suppose there are multi-locational godowns, factories, warehouses, and a company is having multi-locational factories. So now the problem is, from the warehouse the raw materials needs to be dispatched to the different factories. The figures in the first row, the figures are 8, 5, 2. There are 3 factories X, Y, Z, and there are 4 warehouses A, B, C, D. So what this 5 indicates? 5 indicates if you want to transport from warehouse A to factory Y, then you have to spend 5 rupees per unit transportation. Per unit transportation. So all the figures inside the matrix imply that every warehouses are having their capacities and every factories are having their demands, requirements. So those are furnished here 500, 700, 300,000, and here the figure of the demands 800,000 and 700. Now we have to find out the solution. Solution means from which warehouse to which factory sheds we have to dispatch the material and how much we have to dispatch. There are several methods for getting the solution. So today I am just showing you the first method, which is called northwest corner method, NWCM. So northwest corner method, NWCM. Now in the northwest corner method, I told you that there are 2 decision making areas, from where to where and how much. So according to northwest corner method NWCM, from where to where there is no mechanism to take this decision. This decision has been taken bluntly, as the name suggests, that we have to pick and choose the northwest cornered cell of the entire transportation matrix. So that means from which warehouse to which factory, that is decided based on the name of the solution process, northwest corner. How much will be decided logically and maintaining the heuristics. So let us see, this is the matrix. So which one is the northwest cornered cell? This one. Of the entire matrix, this one 8. This cell is the northwest cornered cell. So as the name suggests, we have to select this cell bluntly without thinking twice. Now after selecting this cell, the next question is how much to allocate. When we select this cell, that means already we have decided that the material should be dispatched from warehouse A to factory X. From warehouse A to factory X. Now the question is how much? So you see, warehouse A is having the supply capacity of 500 units and factory X has the demand of 800 units. Now although factory X is having the demand of 800 units, but the total demand cannot be satiated from warehouse A because warehouse A only has the capacity of 500 to dispatch. After that it is completely exhausted. So that means how much to allocate? We have to allocate 500 units only. Why? Because warehouse A can supply only 500, not more than that. So warehouse A is completely exhausted. Means it cannot supply any material to any other destinations, any other factories, because now it is fully empty. And out of 800, 500 units being satiated by A, so factory X is still demanding 300. So factory X has still a demand of 300. Let's see that which other warehouse is ready to dispatch this 300. Now after crossing this first row, why we have crossed the first row? Because warehouse A is fully exhausted. So right now there is no use of keeping warehouse A in our system. So that's why we have scratched the first row like this. So after scratching these, now this is the order of this is the matrix starting from B. Now if I consider this is the matrix, then which one is the northwest corner cell? Again this one, having the unit cost 10. So now we have to consider that now we are willing to transport from B to X, from warehouse B to factory X. Why? Because as per the name suggests, northwest corner method, we are bound to select this cell. When we are selecting this cell, means we have already decided that now we are dispatching material from B to X. Now the next question is how much? So here you see B has the capacity of sending 700, but X needs only 300. No meaning of sending 700 because again the material will be returned because the demand is only 300. So although B has the capacity of sending 700, we will not send 700, we will send only 300. Only 300 because the demand of X is 300. Now the demand of X is completely satisfied. It has got the material 500 from warehouse A and now 300 from warehouse B. So that's why column X is of no use now, because X will not demand any material from any warehouse. No. That's why we have cancelled this column fully. Now this is the size of the matrix with 3 rows and 2 columns only. So if I consider that this is my matrix, then which one is the northwest cornered cell? This one. So once I select this one, means what? Means I wanted to dispatch the materials from B to Y. Now since I have dispatched 300 materials earlier, so the capacity of B is now 400 only. So the capacity of B is 400. B can dispatch only 400 materials. However, Y needs 1000. So just give 400 from B. So warehouse B is now fully exhausted. It is over. It is completely exhausted. And earlier Y had the demand of 1000 materials. So now the demand of Y is reduced by 400, and currently it is demanding only 600. Now the matrix is reduced to a 2 by 2 matrix. 2 by 2 matrix. So which one is the northwest corner cell or valve? This one, 9. So once we select 9 means what? Now we are willing to dispatch materials from warehouse C to factory Y. From warehouse C to factory Y. Warehouse C is having the capacity of 300. Factory Y still needs 600. So what should be the allocation over here? Only 300. Why? Because C cannot supply more than 300. The capacity of C is only 300. So C is completely exhausted and factory Y is still having the demand of 300 units. Now by default we have to allocate. Now there is no rule to apply. Why? Because only the 2 cells are unallocated. Y has the demand of 300. So dispatch 300 to Y from D, and Z is having a demand of 700. So send those 700 materials to Z from D. Therefore D is now completely exhausted because it has given 300 to Y and 700 to Z. Z is also completely satiated. Since the transportation is balanced, means the demand is equal to supply. So both the sides are equal. So we have complied with all the supply capacities and demand of the factories, warehouses and factories respectively, and according to the name suggests, we have solved the problem. Now the question is how to get the total transportation cost, TTC. So now I am finding out TTC. Total transportation cost. So how to find out? 500 units we are dispatching from A to X. And what is the unit cost of transportation? 8 rupees. So per unit we have to spend 8 rupees and we are dispatching 500 units. So that means 500 units into 8 rupees. That would be the total transport cost for dispatching materials from A to X. Similarly, from B to X, 300 units we are dispatching, 10 rupees per unit, so 300 into 10. Again from B to Y, 400 units we are dispatching, and unit transport cost was 8. From C to Y, 300 units we are dispatching with a unit transport cost as rupees 9. D to Y, 300 units we are dispatching and 10 rupees per transport unit transport cost. And lastly D to Z, 700 units we are dispatching with the unit cost of 6. So this is the total transport cost. Comes like this: 4,000, 3,000, 3,200, 2,700, 3,000 and 4,200. So 7,000, 10,200, 12,900, 15,900, 19,900, 20,100 I suppose. If I add, once again I am checking, 7, 10, 7, 10, 13, 17, 19, 19 and 2 to 400 and 700 means 1,100, yes. So 20,100 is the total transport cost according to the northwest corner method. Now if we apply the other methods, the cost may be different, and that's why we are not sure that this is the minimum transportation cost. At max we can tell that this is the transportation cost through NWCM, but our objective is to minimize it. So how to do that? So for that we have to go for the optimality test. And I told you earlier also that there are two processes through which you can do the optimality. One is stepping stone method and second one is modified distribution method. So the popular one is the modified distribution one, MODI. So whichever method you implement, you apply, you have to go through the optimality test. That is a compulsion. Otherwise you couldn't understand that whether this cost is optimum cost or not. Now before going to the optimality test, we have to check one thing: whether this solution is a degenerate solution or it's a non-degenerate solution. If the solution is degenerate, then directly we cannot make it enable for the optimality test. So how to understand that whether this one is degenerate or non-degenerate? We have to count the number of cell allocations. We have to count the number of cell allocations. Here 1, 2, 3, 4, 5, 6. 6 allocations are there. You see, one allocation, second, third, fourth, fifth, sixth. 6 allocations are there. So if the number of allocations is equal to or greater than m plus n minus 1, if the number of allocations are greater than equal to m plus n minus 1, then the solution is non-degenerate. Now the question is, what m stands for, what n stands for? M stands for the row number of the transportation matrix, n stands for the column number of the transportation matrix. So here you see, there are 4 rows. So the value of m is 4. There are 3 columns. So the value of n is 3. So m plus n minus 1 is 4 plus 3 minus 1, 6. And total number of allocations are also 6. So if the total number of allocations or allocated cells, allocations greater than equal to m plus n minus 1, then the solution is non-degenerate. So it's a non-degenerate solution, and that's why without doing any kind of adjustment or insertion, directly we can go for the optimality test. And if it is a degenerate one, that means the number of allocations less than m plus n minus 1. Suppose there are 5 allocations, but m plus n minus 1 is 6. Then we have to break the degeneracy by doing a dummy insertion. If we are down by 1 allocation, then we have to find out the minimum value where the allocations have not been occurred. The minimum cell where no allocation been done yet. So in that minimum cell, that means minimum cost oriented cell, we have to give a dummy allocation and we will make it 6. So this is how the degeneracy can be broken. So we will discuss about the degeneracy elaborately, because this is only the technical part of it. But what is the philosophy of degeneracy? What is the inner meaning of degeneracy? That is not the subject matter of this class. So we will discuss it later on elaborately. What is the inner meaning of degeneracy? What is the implication of that? But in the working front, if we get the degeneracy, first we have to break it by inserting the dummy allocations, and then only we can go for the optimality test. If there is no degeneracy, there is no problem. Directly we can go for optimality test. So what is degeneracy and how the optimality test can be done, that we will discuss in our next appearance. Thank you so much.